welcome everybody at Demo Day and the award ceremony of the second Cassini Hackathon, Connecting the Arctic. I am so happy to be here with my co-host, Anne-Catherine. Anne-Catherine, welcome. How do you feel?
Thank you, Danny. I feel very excited about finding out the winners of the Cassini Hackathons tonight.
Oh, so am I, Anne-Catherine. 270 participants have been working the past weekend on 3 challenges: safe passage at sea, life on land, and caring for our wildlife. 72 projects have been submitted, and tonight we're gonna see the pictures of the winners of the 10 local hackathon organizations. I am looking forward to that more than anyone else. But first, I am very pleased to introduce our first guest on the virtual stage, Mr. Guillaume de Labroche. Guillaume is Head of Unit Space Innovation, Startups and Economics at the Director General of Defense Industry and Space. Mr. de Labroche, Guillaume, welcome tonight. We are so happy to have you with us. Hello there.
Hi, good evening. Hi, everybody. I'm very happy to be with you today. It's a pleasure to welcome you all at this Hackathon Demo Day. I had the occasion to follow you from time to time over the weekend. And to be honest, I found it really amazing the way you worked all together during a weekend, highly committed with such an enthusiasm. So it's quite nice to see such passion. I think we can be very proud of all what you've done. I mean, we had, as you said, we had more than 70 teams, more than 300 participants connected in 10 different European cities. So to me, it's really a demonstration on really the commitment of this generation in terms of entrepreneurship, in terms of global responsibility. Because I think what we've done, what you have done over the past weekend is extremely rewarding. You have worked on an individual basis to develop ideas, very good ideas, concepts that will have an impact on global responsibility for Europe, which is how we can really preserve biodiversity, sustainable development of the Arctic. So for me, it's fascinating to see that, you know, through local ideas, local initiatives, you can have an impact. You can have an impact on what I would call is a common good. It's very rewarding for me, for my team, for us, Commission as well, to see that, you know, space has an impact. Space is an enabler, and space is part of the solution. What we saw is that through Copernicus and Galileo, we can use those services to tackle global challenges, and that again very rewarding for us. You know, designing and sometimes it's very complex, you know, to engineer such programs, but having such an impact that we see through you is very rewarding for us. This is not the end. I understand that now the 10 best ideas will have to be pitched, that we will have to select the 3 most innovative ideas. So this is extremely motivating, you know, that the 3 best will be offered mentoring. So this is extremely rewarding, and I look forward to the selection of the 3 best ideas and solutions tonight. Thank you very much, and congratulations again to all of you.
Thank you very much, Guillaume, for the nice words. Indeed, the participants have put in a lot of effort over the weekend and great enthusiasm. So without further ado, let's see what's ahead for tonight. So first we start with introducing the jury members for tonight. Joining us from the European Agency for the Space Programme is Katerina Strelchova, Market Development Innovation Officer. Katerina is a specialist in space technologies for aviation and supporting startups with the development of new solutions leveraging EU space technologies. Hi, Katerina.
Hello to everyone.
Hi, welcome from my side as well, Katerina. Our next jury member, Ann-Katrin, that joins us is from the FMI, and it's from the Finnish Meteorological Institute, and that's Mikko Stralendorf, and he's a space advisor at the Ministry of Transport and Communications at the Department of Arctic Research. Mikko, you have been busy with GMES, also with the preparation of Copernicus. You have been busy with product development, and I can see you nodding, so I'm still right. And you have been working on weather forecasting. So we are very glad to have you here on board of our jury. Welcome. What do you expect tonight?
I want to see a tough race for the win. And I'm sure there's interesting stuff in there. But thank you for all the proposals. It's good to see.
Thank you, Mikko. Our next jury member is a familiar face for those of you who have joined the Big Ideas campaign. He's one of the people responsible for providing the participants with access to the Wikio this weekend. Fabrice Messel is a user experience and capacity development manager at Mercator Océan and is also involved in the Copernicus Marine Environment Monitoring Service. So he's well placed to evaluate the winning pitches tonight. Welcome, Fabrice.
Hi, everyone. I'm very pleased to be here with you tonight, and I look forward to seeing all the projects. And before the final, I would like to congratulate the organizers for this successful event, and obviously all the participants for their hard work and their shared passion for the Arctic and Earth observation. Thank you.
Thank you, Fabrice. That will definitely help them forward, and at least the 10 best winners to give their pitch tonight. Last but not least, our final jury member, and I have to admit, Ann-Katrin, our jury is really rocking tonight. So thank you for that, everybody. Our last jury member is Katrina Chambers. She's technical manager at Alpine Space Ventures, but the past 18 years she has spent a lot of time working at SpaceX, which is globally renowned, and she was active over there as an avionics specialist. So she brings in deep space tech knowledge. Katrina, welcome tonight. What are your expectations from the pitches tonight?
Oh, thanks for having me. Yeah, I'm very excited to see what everyone's going to put together. I'm sure it's going to be well thought out and looking forward to seeing the pitches.
So welcome all, everyone. Now that we've met the judges, it's time to meet the teams. We will hear from the winners from each of our 10 hackathon locations. Each of the winning teams has nominated one member who will make a 2-minute pitch and take questions from the jury tonight. Let's get started.
Yep. So for the teams that are pitching, we really like to understand that they keep track on their time. That's 2 minutes. If they hear a ring, then basically, or a buzzer, that means that we will intervene and stop the pitch in a few seconds, basically, Ann-Katrin. And we really have to take care of time because our jury members need also some time, about 2 minutes, to be able to ask some questions. We are running a little bit in advance of schedule, so that gives jury members maybe a little bit more spare time to pose questions. And obviously, we'll give the word to the jury members immediately after the pitch. But let's kick off, because that's why we are here tonight, to understand which projects are going to be presented to us. I think the first one, Ann-Katrin, is the winner of the Croatian Hackathon. If everything is right, we have Ivan Porubsky with us. Hi, Ivan. We would like...
Hello.
Hello. We would like to hear everything about your project We See, which you can also see in the background. So, floor is yours for 2 minutes. Best of luck to you.
Thank you. Hello, my name is Ivan, and I'm here to pitch We See, an Arctic monitoring system. On the 23rd of March this year, a ship named Evergiven disrupted an important shipping lane that connects Europe and Asia. 6 days later, the Suez Canal was unblocked, traffic continued, but there was an estimated $1 billion of damage done to all parties involved. And this got us thinking, is there an alternative? Yes, there is. The Arctic shipping lanes. The Arctic shipping lanes provide a benefit of faster shipping time and less fuel consumption, but there are some issues that need to be tackled first, such as the dangerous Arctic conditions and the lack of infrastructure and support. This is our solution to this problem. WeSees, a system consisting of a software prediction model, satellite coverage, on-site hardware, and network ships, working together to provide a reliable maritime passage in the Arctic. WeSees Solution Edge is built on Sentinel data for monitoring short-term ice movements and Galileo's precise navigation for route optimization features. There is already a sizable shipping market worth $1.5 million that would be interested in our solution, and that market is expected to grow by 25% each year. Other opportunities include Arctic tourism, fishing, and more. To capture these markets, we would start with a minimal viable product, core software that analyzes satellite data. From there, slowly include on-site sensors and ship equipment such as radar, finalizing our infrastructure, an infrastructure that unites space, land, and sea. That is our vision. That is what we see. This is no easy task, but our diverse team is up to the challenge. Our UX developer, Petar, our software engineer, Stipe, and myself as PR and head of sales on the team, together, we will move glaciers. This hackathon was an amazing opportunity to see what's happening in the Arctic, but only with your mentoring, your guidance, and your financing, we can make this opportunity a reality, because we see to it that vessels make the right decision at crucial moments. Thank you.
Thank you very much, Ivan. What an opening pitch. I think I'm lucky that I'm not part of the jury, but let's give the floor to our jury members. Ladies and gentlemen, do you have any questions for Ivan?
You mentioned some on-site sensors or hardware. What sort of thing are you considering in the Arctic environment?
So we would like to build something that is low power. So we're not talking about high data bandwidth. We're talking just simple signals that will relay signal data. So we would like some sensors on site that gather data that is unavailable to satellites, such as seismic activity. So for example, let's say we predict via satellite that an iceberg might collapse and pose a threat. We would like a network of cheap disposable devices, at least for the first version of the infrastructure, to provide real-time informations if any hazards occur, because we want to be really sure what's happening.
Yes, Mikko?
So Mikko has another question. Icebreakers are still necessary for the shipping routes. So how would you interact or organize your business with them?
Of course, there would be a vital part of it. Because I mean, with global warming and the melting ice, shipping lanes will become a bit more accessible. But for now, icebreakers will be needed. We would, of course, have a partnership going, and we would like to utilize their hardware available on ships. So let's say there's a sudden chunk of ice that might pose a threat, but the satellite didn't pick up on it yet. The ship's radar will, which then relays that information on our on-site infrastructure, getting it to either via satellite or to headquarters for model software, so software modeling.
So you have mentioned the market size of $1.5 million. So have you been thinking, you said the next steps is a minimum valuable product. So do you have already in mind some customers that you would like, potential customers you would like to team up, or how you would validate your MVP?
You mean like specific customers or just
Yes.
like general markets? Well, Maersk.
Or who are you targeting exactly?
Our first target would be any shipping company that does trade via the Arctic trade routes, because of course we want to make the environment more secure for them. We haven't really reached out to them yet because it was only 2 days, so we didn't have the time. But we feel pretty confident that we could make a good deal with them.
Any further questions?
No, because we have still 30 seconds left for another question. But if no other question, thank you, Ivan. And obviously, best of luck, Anne-Catherine.
Yes, next up, we are going to the Hackathon of Finland and see the winner there. Welcome to Dang. Could you please tell us a little bit more about your project Sea Route?
Yes, sure. So, yes, ice is melting, passages are opening, and more ships are coming to the Arctic region, especially cruise ships. A visitor can pay up to 9,000 for just a cruise like that. But there are accidents when ships hit ice or seafloor and get crowded. That results in oil spills, causing marine pollution, affecting lives of both man and wildlife. Now, what is the reason for that? It is because ships are using outdated navigation systems, while the Arctic Sea is highly unstable and unpredictable. This calls for a more advanced, accurate solution. Luckily, Sea Route is here for the rescue. Our solution optimizes routes, offer more accurate and timely navigation using richer data. We use Galileo and EGNOS, Copernicus, and also external data, utilizing computer vision, machine learning, and ship network to not only monitor, but also to forecast ice, seabed, ocean current, weather, and also wildlife. Our navigation, safe navigation, is the core of our solution. Sea Route ensures safety for people on board, reduces insurance costs for ship operators, costs for rescue and cleanup efforts, minimizes marine pollution, and also cares for the wildlife. Our product will follow a subscription-based model. The target customer will be cruise ships operators, first in the Arctic, and then expanding to other sea areas, and also other customer segments as well. To make this happen, our team of 4 consisting 1 software engineer, 1 data scientist, 1 designer, and myself will be the driving force behind Sea Route. Hopefully, there won't be 500 accidents per year anymore in the Arctic Ocean. Interested in our ideas? I'm more than happy to discuss with you.
Thank you very much, too. Indeed, the floor is open for questions from the jury.
Yes, thank you for the presentation. What is your solution to validate the rules?
Can you repeat your question a bit? I cannot hear it clearly.
Okay, can you hear me?
Yes.
What is your solution to validate or qualify your optimization rules?
So basically, the idea is utilizing the network of the ship and also the navigation systems. So we have the prediction, and also whenever we have the chance to connect with the internet, it will be updated, and then it will be like validating with our algorithm. And so it improves after that. Yeah.
You mentioned a number of things you were trying to capture, like sea currents, etc. Which of those things would be a new development for the team versus something that's been developed before?
So for now, it's we have run the data for the ice and also for the seabed. So and there is also for the weather also. So in the future, we would like to look into the wildlife. There is a recommendation or guidelines from the wildlife World Wildlife Fund to have a safe distance from the wildlife. So the best is that we have an optimal route to go around all the obstacles, but at the same time, like we not like go too close to the wildlife. So we have like a safe distance to them.
Thank you.
Yeah.
Mikko or Katarina, do you have any questions?
If there's still time,
sure.
I might just ask for the, when you also are interested in the seabed, the satellites that are measuring the height of the sea level, they unfortunately only go up to 60 degrees north. So the Arctic has a special problem there. Are you having any ideas of a solution for that?
I think it's more about like utilizing the data from other sources as well. We have like, planned a partnership with other research centers where they have like the ships going and researching the area. So for example, VTT in Finland, and also, I can't remember it now, but there is also others researching organization, that we can exchange our data to them and they can exchange data to us. I think that's like beneficial for both of us.
Katarina,
Just
yes?
Yes, I have one question. So you were saying that you are using basically the GNSS data, Copernicus data. How updated this data, or how often you update this data in order to be able to optimize the routes?
The most frequent is once per hour. That's according to my team, they say. And then we will be also using the computer vision learning, and then also like for the algorithm we have. So we will be updating and constantly learning for that to be more accurate.
Okay, thank you.
Yeah.
Any more
Do you
questions?
have any questions? Yes, maybe about like how do we reach our customer, for example?
That's obviously something that, yeah, go ahead. How do you reach your customer?
Yeah, so it's a cruise ship, and there is an organizations for cruise ships in the Arctic and also for Antarctica as well. So our first going is reaching them. They are promoting safety for their members, and of course they would be interested in this. Then next is partnering with also like insurance company, because of course having safety for the trip would prevent them having to pay money. And at the same time, there are in the future we have planned for cooperating with, let's say, engineering companies like for steering and engine of the ships, like ABB in Finland, for integrating with the steering system, so it's smoother for the whole trip.
Well, thank you so much too.
Yeah.
If the jury has a single last question to pose, then now is the moment, or otherwise we have to say goodbye to two. Yes, Katrina?
Are you just using satellite data, or were you suggesting using something else in the previous answer?
Yeah, we'll be like using the ship network with others, and also like external data from other research center if we can connect with them. So they have the ships going and scouting the area. So it would be good to exchange data with them.
Thank you.
Thank you for this question, and thank you for your clear explanation too. We wish you from the organization the best of luck in the coming minutes. Anne-Catherine, what an idea it was. Huh?
You know what it makes me think of?
No.
Like ways for Arctic sea routing.
Yeah. And also basically taking into account the future feature of navigating to preserve wildlife is probably something new for the logistics sector as well, I suppose.
Bringing in sustainability, very important indeed.
Very important. So I think Tu's idea, or the Tu's team's idea, might have a touchdown in the logistic sector. And they already thought about going to market and reaching customers. That's really cool. Tu, thank you very much. Bye-bye and see you later.
Yes, thank you. Thank you. Yes.
I think we are almost ready to go to our next hackathon winner, if you ask me, Anne-Catherine.
Yes.
Yeah. Our next winner is coming from France. And her name is Zoe Strubel, if I'm pronouncing that right. Hi there, Zoe. Welcome.
Hello.
Okay. How do you feel?
I feel enthusiastic, but also a little bit nervous.
Okay. It's good to be a little bit nervous and a lot of enthusiasm. That's always a good combination to pitch. The previous candidates did fine, so basically that's where the bar is at this point. We're gonna wish you all the best of luck in your pitch, and you're gonna tell us more about your project IceBlink, if I'm right, correct?
Yeah, that is totally correct. And I agree, the previous presenters did a great job. Oh, okay. Bonjour from France. Our project IceBlink is inspired by my experience as an Alaskan born in a village above the Arctic Circle, and that of Vincent, who's a polar navigator. As we know, sea ice is a major obstacle to safe passage for local populations. This is especially true now because of climate change, as the rhythms of sea ice formation and melt have become more unpredictable. To respond to this need, Sardar and Laura have developed an easy-to-use tool that employs Galileo and Copernicus data. With our team's combination of on-the-ground expertise and technical skills, we have created a service that is adapted to the constraints of the Arctic, which includes long polar night and low connectivity, is affordable and accessible for local populations who may live subsistence lifestyle, their communities, researchers, and small vessel navigators, that is easy to use regardless of technological expertise, and most importantly, that responds to an unmet need. So how do we achieve this? We use Sentinel-1 radar data to map daily sea ice conditions. Our method produces a grayscale product that indicates sea ice, open water, and areas where there's a mixture of both in an easy to interpret format. In terms of user access, our design is simple and deliberately low tech, tailor-made for our users. First, users send an email with their GNSS coordinates to iceblink@gmail.com. Second, a radar image is downloaded, processed, and classified via ADIAS. And 5 minutes later, users will receive an up-to-date ice map centered on their coordinates via email. To maintain a low data use product, our image is delivered in compressed PNG format and covers a 160-kilometer radius around the user's location. Our images can be downloaded with both 3G cellular data around villages and through the Iridium service in open water. We have a working prototype that meets all these needs. Our tool is accessible and useful to those who live, study, or work in the Arctic, regardless of their economic status. We can all agree that everyone deserves a safe passage at sea.
Awesome.
Super, Zoe. Thank you. Awesome pitch. So there was no reason to be nervous about this one. But I am sure our jury... I'm sure our jury has some questions for you to answer. Ladies and gentlemen of jury, maybe Fabrice, you could kick off. I can see you waving.
Yes, thank you for your presentation, your pitch. Why did you choose a solution based on email?
Okay, so the solution based on email, first of all, a great question, because I know that that can be a little bit shocking in 2021 to have an email-based solution. But knowing not only local populations in the Arctic myself, but also exchanging with Vincent, having a web-based service which uses a lot of data isn't a good option in the Arctic. There is not a lot of connectivity. So we wanted something that would use low data and would also be easy for users of all technological skills to be able to access.
Can you tell us a bit about your team?
Yeah, I would love to tell you about my team. So as I said, I'm from an Inuit village in Alaska above the Arctic Circle. We also have Vincent Grisson, who is an Arctic explorer. He's spent a lot of time navigating Arctic seas, and it's thanks to him that we were able to really focus on the needs of someone who's navigating these waters as a small vessel. Afterwards, we have Sardar Rama, who is in charge of our radar and remote sensing. He kind of was able to tell us what kind of treatments in order to make them useful. And then last but not least is our friend Laura, who is our programmer, and she's in charge of automizing our whole process. She's able to tell us what we can do, how much time it will take, and whether we need to have le main de soupe, whether we need to intervene or whether the process can be created without us, if that makes sense. I hope that was clear.
How expensive will one kind of image be for an Iridium phone user?
That is a great question. So I'm not the expert on the Iridium system usage. That is something with Vincent, but who cannot answer questions. As far as I know, the Iridium service functions somewhat like a cell phone subscription. You pay for the service or not. I don't think you have to pay just by image, but our images are very small. So even if the data has to be paid for individually, you have to pay for each image. They're roughly, and we kind of calculated this with the test, they're just 300 kilobyte images. So even though they cover this big radius, they're as low data as they can possibly be. And Iridium service is ubiquitous for people who are traveling outside of areas of cell phone coverage. So it's not a tool that someone would have to necessarily buy in addition if they're navigating polar seas. It's something that they would already have on board.
I have a question. So you are saying that you are providing these maps via email, but how is the whole process? How the user that needs these maps requested it to you, and how he defines what kind of area that he needs? And are you able to cover the whole area, or?
Yes, so the way that they ask for an image from us is they simply write us an email and have their coordinates in the email. That's all. Afterwards, our code, in theory, well, actually, no, we've tested this part. Our code will be able to read the coordinates from the email directly. And then we look for the Sentinel-1 image that's the most recent, that covers these coordinates and has a buffer of 160 kilometers around this coordinate location. The reason we said 160 kilometers, it's about what a typical small vessel navigator, a 24-foot boat with a 250 horsepower motor will travel in a day. And so using that subset, we cut the image, we post-treat it, we classify areas of sea ice, open water, and pixels where there's a mixture. The darker the pixel, the more open water, the lighter the pixel, the more sea ice. And then we send them just the zone that they need, which keeps it low data, but contains all the pertinent information for them. And we send it back to them.
Mm-hmm. And did you think how fast you have to be with your response, or where they have to send this request? Because what is my question is, sometimes you want to go with your vessel and you have to plan in order to get your image. So how flexible you are on that?
Well, the image treatment with the test that we've run takes about 5 minutes. So they can send, they can make the request and receive the image quickly. As far as planning too far in advance, it really doesn't make sense when you're trying to plan around sea ice conditions, because within a few hours or half the day, the conditions can be quite different. So you don't want to request these images a week or even days in advance. You want to request them right before you go out, or even when you're on board.
Okay, so you're confident you're able to provide it within 10 minutes to every request you will receive?
Yeah, totally. We've done tests. That part I'm sure of.
But how old are the images on average? Because every day there's not
it depends on what. Sentinel-1 coverage, at least of Northern European waters, this is not, however, true in Alaska, but of Northern European waters, is daily. Obviously, when we think about the future of our project, we would like to, with our premium offer, add more access to more data, such as ICE-Eye or radar sats, and that will increase, it will increase the price, but it will also increase the temporal resolution of our images. So the maximum is 1 day, but the minimum, especially with projects like Crystal or the new L-band SAR that's going to be launched soon, I don't know the exact date, we can hopefully increase the temporal resolution, but it shouldn't be more than 12 hours.
Thank you.
Super. Any last question to Zoe from the jury? No?
I'm ready.
We know you're ready, Zoe. You are really enthusiastic, and we wish you all the best for tonight. And thank you so much also to your team members for participating in this hackathon. So looking forward. Thank you very much. Anne-Catherine, this was a team with ground floor experience.
Yeah, absolutely. They knew what the needs were of the people in the Arctic.
Yeah.
So indeed, they came up with, and they've done a lot of research. All of the space technologies that they mentioned, the different satellites, the fact that they used both Copernicus and Galileo and satellite communications, they've really captured the spirit of the Cassini initiative.
Yeah, interesting angle you take over here, because you know what struck me most in the pitch presentation?
Tell me.
Basically, the disruptive character of the idea. They were integrating high tech and bringing it in a kind of low tech, just good enough, or maybe just not good enough character to the market. And that really triggered questions with our jury members. We could see the dynamics and how will it work then and what will it be delivering. And I think Cassini hackathons are basically meant with the objective to rethink what we consider as normal. So yeah.
Absolutely.
I think the jury has some time to think about that. Shall we slightly go to our next pitching candidate, Anne-Catherine?
Yeah, I think it's time to hear from the winner of the hackathon in Germany. Welcome, Thomas Metcalf of Project Polar Bearings. Are you ready to do your pitch?
Absolutely.
Go ahead. 2 minutes.
Okay. So we are Polar Bearings. That's Steph, Elaine, Ian, Yorit, Vibhav, and myself, Thomas. In the Arctic region, most communities are isolated and depend heavily on roads that cross frozen lakes, rivers, or the sea. With global warming, these connections are continually becoming less and less reliable, which poses a threat to personal safety and the prosperity of communities, culture, and commerce. Navigating icy terrain with limited knowledge of ice safety results in over 200 deaths and 14,000 injuries each year in North America. Polar Bearings is an AI-powered Arctic navigation platform that offers safe and optimized route planning for terrestrial vehicles over icy terrain. During the hackathon, we developed a POC mobile app applying state-of-the-art artificial intelligence trained on ice thickness and temperature data from Copernicus satellites to determine ice trail safety in real time and route users along secure paths across northern Canada. Combined with Galileo positioning, weather data, and terrain contour maps, we could provide an innovative navigation solution that currently does not exist for Arctic communities. Our data analytics has the potential to benefit local authorities, environmental monitoring institutions, and rescue and wildlife protection agencies to improve their services with remote capabilities. We are a passionate international team with strong backgrounds in machine learning, UX, and sustainable product design, in addition to physics, IT, and marketing solutions. Elaine, our Canadian business development expert, has over 20 years of management experience in the space sector. After our MVP is realized and tested with users in the Canadian Arctic, we want to adapt our solution to other Arctic regions, but only with your guidance and mentoring can we make this a reality. We are Polar Bearings, your North Star over Arctic terrain. Thank you for your attention.
Perfectly on time. Well done. I believe our jury members will have some questions for you.
Please.
Yes, can I start? Yeah. Thank you, Thomas, for the pitch. Have you considered assimilating user measurements on your platform?
Yes, absolutely. Use it as in end user measurements.
Yeah.
Yes, absolutely. So this is part of our rollout strategy that we're going to be conducting interviews and surveys with local Inuit communities and scientists and researchers in our first use case of the Northern Canadian Arctic, and integrating their local knowledge into our database so we can improve our accuracy of our models, learn about the trails they're using and ways they avoid, and basically begin mapping out our routing.
And what about real-time measurements?
Yes, absolutely. So the way this works is that in our current solution, we are training machine learning models based on historical data. So we have these measurements from Copernicus, and we begin predicting ice trail safety sort of measurements across time. And our route planning algorithm takes those measurements into account. And now we will then deploy such models onto our end users' apps, onto their embedded systems in their vehicles, and such that when we say they're getting real-time value scores, it's because the model is continually predicting and making sure that their route is safe as they're traveling along it.
What is the business for you? How you will basically, how you will sell this solution?
Yeah, so we're going to begin, again, we'll start off in the Canadian Arctic and interacting with, well, so initially will be the Inuit communities, again, the researchers that live there, and people like the park rangers and the wildlife communities, logistics also between towns, and healthcare staff. And this will be our first end user segment. But as we said, the vision is that over time, this is just the beginning for us. Like we have a strong vision that the data analytics that we will begin to collect through this route planning will be able to use for wildlife protection, rescue services, environmental monitoring institutions, and basically giving a more accurate view of the terrain that's currently quite difficult.
Thank you.
Yeah, thank you for the question.
There's a global land product on lake ice, for example, in the Copernicus data. Have you compared with it? Are you using it somehow?
Lake ice, you said?
Yeah, there's a lake ice product. It's based on MODIS data mostly. Have you compared with it, or how do you integrate with it?
Our prototype was based on the coastal regions of the Canadian Arctic. So we were focusing on fjords, crossing ice bridges across very small portions of seas. The lakes is something that we are studying in depth. This data is, of course, like we can use it in our algorithms just as easily as we've been using the fjord data. So yeah, it's a mix of both.
You said you produced a mobile app, maybe not quite your final product yet, but what kind of thing are you thinking there? Is this like a Google Maps type thing, or like what is it?
Yeah, exactly. So it's in the same vein as a regular routing map. So this app would be sort of syncing when your user is in the towns and updating the sea ice thickness models continually. And then you'll be planning routes from town to town with this app. The app would then provide you like navigation along your route. And again, this is just part one of our sort of marketing strategy. The app is definitely like something we've already achieved and something we can continue to develop on. But we also see use cases for embedded systems where we have, let's say, logistics companies or, again, healthcare that we have snowmobiles with this app integrated into it. And so we can use our navigation for safe passage and save their lives.
Are you trying to plan the route, or is it to provide the data to plan the route?
So we also provide the route planning algorithms as well.
Are there any further questions from the jury? If not, I have a quick question for Thomas. Are you actually in the Arctic? Because it seems like you're wearing a very warm coat.
Yeah, it might be chilly out here, that's for sure.
Well, thank you very much, Thomas, for your pitch. Good luck for the rest of tonight. We'll hear later on if you may have won. Danny, what did you think? It seems like safe passage in the Arctic is a very popular topic tonight.
Yes, and everybody's taking a bit of a different angle to it. As I understood this pitch, this product would improve the lives of the people living there, basically. And that's again a different viewpoint than the other teams. Yeah. So I'm surprised that all of these countries, they pick winners, and we haven't seen a second topic passing by so far. So, and by the way, Anne-Catherine, in our Big Ideas campaign, I was really surprised to understand that there are quite some people living at the Arctic, because we got important countries like Sweden, Finland, Norway, Canada, Russia, Greenland, and maybe I'm forgetting a few of them. So we are talking about a huge number of people over there.
Yeah, absolutely. No, I'm excited to see all of the creativity that came out of the weekend, the ideas, the research that everyone has done. So some very nice solutions that we've seen already so far.
Yeah, thanks, Thomas. And we have to go to our next pitching candidate, and we are almost halfway. and we are basically moving upwards towards the Arctic with the winners from Iceland. If everything is fine, we have Cécile Chauvin with us. Hello, Cécile.
Hello, can you hear me right? I hope so.
We are hearing you fine, and with the
Perfect.
headphone you should hear us as well, I suppose. That's,
yes, I hear you perfectly.
Super. Cécile, did you prepare a bit for this pitch?
I hope I prepared enough. I think so.
You have been practicing. Good, good, good. Because
Yes.
we are really curious to see what your project is all about. I think it was called Arctic soil erosion, if I'm right.
Yes, let's just say that we prepared so much for the technical part that the name was kind of an afterthought, but it's definitely a work in progress.
Super, Cécile. That's how it works after a hackathon. It's not the end of a journey, but the start. I will give the floor to you for 2 minutes for your pitch, and afterwards we can return to the jury. Floor is yours, Cécile. All the luck.
Thank you very much. So my name is Cécile, and I'm just going to talk to you about our team's project for Arctic erosion. So I'll start with an interesting fact. The upper layer of the soil in Iceland can store up to 80% of carbon. Because of climate change, that upper layer of the soil is being eroded away and basically broken down. And obviously that's releasing the carbon that's stored into the soil, and those gas emissions are contributing to climate change. So there's ways that you can prevent or stop this, but the first step towards that is to know where the erosion is most likely to happen. Our solution to this is remote mapping of erosion risk through satellite data from Sentinel-2. This is a solution that exists nowhere else on the market, that cuts down costs drastically, and that provides continuous monitoring instead of tedious field-based measurements. We are working in collaboration already with the Erosion Conservation Service of Iceland, and this is a game changer for them because it allows them to pinpoint the areas where they really have to look and prevent the erosion before it happens. Once this solution is being implemented in Iceland, then we can move on and license it to soil remediation companies that are popping up all over the world, and especially in the Arctic, where melting ice and climate change is making this erosion happen much faster. They need solutions like ours to prevent the damage and stop the damage, because this soil erosion that I'm talking about, it's happening right now as I'm speaking. We think it's time to do something about it. Do you? Thank you very much. And if you have any questions, please ask me.
Thank you, Cécile. You're addressing an urgent phenomenon, and probably our jury wants to know a little bit more about that. Jury members, floor is yours.
So how will you provide this data on the erosion from the Copernicus? And do you have the, is the high resolution or the resolution of the Copernicus enough for this solution?
So yes, we've already tested this during the hackathon, so we know that it works. And we're using, so that's data from Sentinel-2. And basically we're calculating indices of different characteristics of the vegetation cover and the soil types. And that tells us with principal component analysis, we're basically able to see like which of these indices matter the most in erosion. This is a solution that was used before in some research papers, and we're just adapting it to Iceland and making it more automatic. And also we're trying to use another model that was implemented in Canada before. And that is taking into account the moisture levels and the wind, which is really, really important in Iceland because obviously there's so many storms and the wind is like a huge factor. So if we take all of that into account, we can have not a map of where erosion already happened, but actually a map of where erosion is most likely to happen, because then we can prevent these processes that take a long time and that lead up to erosion before erosion that can be very, very quick actually happens. And we know that we have the right resolution for this because we tested it. And of course in Iceland, because we're working with the soil conservation service, they also have access to even higher resolution images that are taken by plane. And this is free for them because they're a government organization, so we can have access to that.
Is it just for an assessment of the soil degradation, or can you, is it possible to have sort of prediction of this evolution of this soil degradation?
So if you're asking if we can predict where the soil is going to erode, that's the whole idea behind this, is to say like, okay, these are the areas where this is going to erode the fastest, because all of these different characteristics are exactly right for erosion. And this is the places where we can do something about it. So yeah, this is going to help the soil companies to know exactly where they have to focus.
Have you tried to look at other areas of the Arctic? The Kola Peninsula in Russia, at least, is an area where kind of soil erosion is a big problem.
Yes. So actually, yeah, I studied the Kola Peninsula before because there's a village there that had to be moved because of the melting permafrost. And we really want to work with this because we think that it's so important to help these people that are being like misplaced out of their homes and have to leave. So we want to make sure that they can know before time that they have to actually like leave and have the feet in the water, that they need to set up their village on higher ground. And the Kola Peninsula would be a perfect place for this because our models can take permafrost into account. And this is something that we're looking to work more with the Soil Conservation Service because they're experts on this.
Do you know how much people will be willing to pay for the data or help with funding for development of proving that these models work?
So we're planning on developing this in partnership with as I said, the Soil Conservation Service, and we're already in talks with them. Actually, we're having a meeting with them very, very soon because they're extremely excited for this product. And we're just hoping that with them, we can get the right funding for our research. And then thankfully, I'm super excited, but we got also a message from one of the judges from the hackathon here in Iceland. And she said that she's also willing to mentor us and she's interested in our project. So we can definitely move forward, and we're very excited. And then, of course, if we also get the 100 hours of mentorship, then I think that we really have a product that will work and we can develop.
A last question maybe from the jury, otherwise we say goodbye to Cecile. Miko, you have a last question, or did I misinterpret the signal? No? Okay.
I'm happy, thanks.
Okay, super. Thank you, jury members, for this interactive debate. I hope you got some more wisdom. I became a bit smarter, Cecile, so I think you were well prepared. And Anne-Catherine, Cecile is already talking to customers. Isn't that cool for a hackathon team?
They're moving ahead, so it's great to see that this is actually also going to go somewhere for the future.
Yeah, absolutely. What struck you most in this pitch?
I liked how they had been indeed talking to different. Or thinking about different areas, different problems, a problem that we hadn't heard yet tonight. So it seems like a very interesting solution that they found.
I think so too, Anne-Catherine. I wish them all the best. And I think we have a new lineup.
Yes, indeed. We're actually at the halfway point now. 5 pitches down, 5 to go. Are you still... ready for the next 5 pitches?
Oh, I'm still energetic, Anne-Catherine. It won't stop until we know who are the top 3, I suppose.
Jury members, are you still ready for the next 5 pitches? Perfect.
Sure.
Great. So then we head over to the winner of the hackathon in Italy. Luca Passeri is going to tell us a little bit about his project, or his team's project, Phyto4C. Luca, the floor is yours for 2 minutes.
Hi, I'm Luca Passeri, and Phyto4C is our solution to the third challenge at this hackathon. We focus on 3 main problems. First, finding sustainable places for fishing and fish farming. Second, detecting abusive behavior or anomalies in the marine environment. Third, allow people to access reliable predictive information. Up to now, fish industry, governments, researchers, and activists use domain-specific solutions. We propose a holistic approach with a predictive model to monitor oceanic flora and fauna, starting with phytoplankton observation. Phyto4Sea aims to be a general-purpose platform for different customers, fishing companies, fisheries, public bodies, and citizens. Furthermore, thanks to the collected data, we plan to develop a proper certification system for the fishing supply chain. Phyto4Sea is fueled by EU data from Copernicus and Wakeo, such as satellite images and Galileo GNSS positioning. All data will be processed in a big data platform with data mining and machine learning techniques, thus creating the artificial intelligence brain, the core of the platform. Phyto4Sea is sustainable thanks to per-pay services to both customers in the fish industry as well as governments and supervisory bodies, access to public funds and strategic partnerships with universities and research groups. Moreover, we aim to provide free limited services to the whole population. Our team is composed by me with Eugenio Perfederici and Eugenio Cavina. Graduated in computer science, we work in the IT sector. Interested in data science and artificial intelligence, we are very sensitive towards the planet and its health. We have an active network with marketing specialists, and we plan to include in the team environmental and aerospace experts. Thank you.
Thank you, Luca. Well on time, within the 2 minutes. Let's head over to the jury to see if they have any questions for you.
So what is the value?
Sorry, Katerina, please.
So I would like to ask, what is the value proposition of the solution? So why are you different than other solutions, similar solutions? And also, second question is, you are saying that all the team is from the IT sector, and then you plan to hire another aerospace or environmental expert. Do you plan to also have somebody from marketing in the team or salesperson? Thank you very much.
Okay, for the first question, our solution differs from other solutions because it uses a general purpose approach, gathering all the data and providing information for different kinds of customers. Up to now, similar solutions are focusing on specific solutions. So our idea is to gather this information to provide more services with reliable data. And for the second question, yeah, of course, we are also evaluating to acquire some skills in the marketing sectors.
Thanks.
Yeah, my question was a bit similar because I would like to understand what is your main argument for choosing the holistic solution, because you are not afraid to not target the correct communities.
Well, I think that the holistic solution could be the game changer because of big data platform and all the data collected by different sensors and satellite images and inside data. And by gathering this data, we think that we will have forecasted data with a more reliable access, and as well as providing different services for different target customers.
Does anyone...
Have you analyzed? Okay, please go ahead, Katrina, if you want.
I was just wondering if you could give an example of, for one of your targeted customers, like what are they receiving?
Okay. For example, we will sell our product to fishermen who want to find fishy zones, and we can forecast information for them. And another example will be fish farming companies for finding areas for more profitable fish farming, and researcher groups too who want to get forecasted data. And finally, also governments who want to maybe finding fish farming that are doing abusive farming of fish.
Yeah, my question is simple in the sense that have you analyzed already fish farms? We already know where they are for a large part. So have you analyzed the existing ones?
Well, we found that by analyzing the composition of the water, and specifically the composition of flora and some other data, we could find fish farms, and then we can get another data to improve this identification, and then maybe selling this information to governments who want to find if there are abusive fish farming. And finally, we also analyzed that there is the correlation between fish farming and flora data such as chlorophyll in the water and phytoplankton.
Perhaps if there are no further questions from the jury, a quick one from me. Since you're a team of data scientists, did you actually program a prototype during the weekend?
Well, we extract the data and we did a little bit of correlation for the data, but the real predictive model has yet to come.
Okay. Well, great. Thank you very much, Luca. Thank you to the jury already. I believe we'll close this off for now so that we can go over to the next one. But perhaps, what did you think of the solution?
Well, I think Luca and his team, they touch quite a substantial problem. We have to preserve biodiversity. And nonetheless, fishing might be a niche market, looking at it from a global perspective, or at least that's my humble perception I got. It's very, very important, basically. And also from a policy perspective, this is a quite important topic that Luca and his team are addressing. So I'm entirely fan of the idea, Anne-Catherine.
Okay.
I think they are really tackling a problem at this point. But I think we have another runner-up in our list.
Yeah, waiting.
And that is the winner from Latvia. Welcome, Artur Bialkowski. How are you doing tonight?
Hi, hello. Well, a bit nervous, but I'm okay, thank you.
You're okay. And probably you're very fine if you're one of the top 3 winners, I assume.
Well, we'll see, I hope.
Yeah, you hope. That's what we all have to do. Have you prepared a bit, Artur?
Oh, yes, well, the whole day yesterday and today. So.
Well, then I think you will do fine in telling the jury members about your project stall. So floor is yours for 2 minutes. Good luck.
Okay. Hello, good afternoon. Our project called Arctic Maritime Situational Awareness is intended to help ship navigators sailing through harsh Arctic seas. What are the major issues they are currently facing? Well, firstly, Arctic sea routes are increasingly accessible and important, but navigation throughout this region can be extremely challenging. Secondly, vast amounts of collected Earth observation data could significantly improve the situation, but they are still underexploited as accessing and filtering them is difficult. Lastly, although also important, gigabytes of EO data need to be exchanged, but transfer capabilities there are very limited. So what is our solution? Using EO data providers like Wikio, we can extract only the data that are relevant for maritime navigation, to name a few: ice coverage and thickness, sea ice drift, water temperatures, and so on, and store them on our servers. One requested on the palm of the captain's hand, our application displays all useful information related to specified route only, presented in visually comprehensive and easy to understand graphs and diagrams. And hey, we even already prepared a dashboard of how it could look like. We believe that with our solution, shipping and its safety in the Arctic can be improved through even more knowledge-based decisions, oceans of data converted into the clear and useful information, and all that, the data bandwidth usage is reduced. Our solution targets mainly the business, cargo industry, tourist cruises, fishing vessel. Income would be based on licensing plans tailored to the specific business client needs. Who are we? A team of colleagues: Piotr, astronomer and data scientist; Artur, aerospace engineer; and Pavel, software engineer with master's degree in business. And well, we really do care about the safe future of Arctic. Thank you.
Super, Arthur. Thank you so much for this lovely pitch. Jury members, who is willing to open the question session?
Yes, thank you, Arthur. You know, a lot of route optimization application already exist, and what is your specificity?
Okay, well, actually, the route optimization itself we have as a future development, because currently our solution and what we find in the concurrent companies and application, we did not find this solution. So what we propose is the information only along the route which a captain or navigator put in the system. So like the GPS navigation in the car, you put the route and then you have information only about your route. So of course it can be in the future configured to have wider space, but having information only the route reduce the bandwidth. So we can send from the servers to the client only the information related to the route which was designed. Our future development is also to make some suggestions or even optimization and so on, but as a basic product, it's just information along the provided route by the captain or navigator.
So how will you do?
On you go.
How will you do the pricing then? So you will be charging per every route that you will be requested, or what is the plan?
Okay, so our idea are the licensing and subscription. So, well, the main goal is the business, and we would like to, have and attract the big business from, and with the big business we can tailor our solution only to their need, even prepare some special version of applications, something like this. But we also would like to have subscriptions for all other and small individual users, because Arctic it's also not only a business, but it's also leisures, and there is a lot of depends, but there are some yachts and kind of leisure activities also. So for them also we would like to provide the information. But well, the main income which we assume for now, it's just licensing from the biggest big companies, and also the subscription. In our mind, the subscription was per some time, but actually this can be evaluated during preparation and optimization towards to the MVP. So.
Thank you.
What do you consider your biggest challenge and also differentiator for other people who are also trying to do similar things?
Okay, so as a biggest challenge, there is also on one hand it's the area of the observation data itself, to access to them and analyze them. So that's also it's somehow a technical challenge, but also from our perspective to reach the clients and attract the clients, and actually to gather the clients, the biggest clients for our service. So for that also we consider we as somehow challenging. And excuse me, but the second part of your question, could you repeat?
Just what differentiates what you're doing versus other people who are trying to solve the same problem?
Yeah. So that's the specific route only. So as we found the solution which we found, we did some research, and the solution which we found was focused on aerial maps and situation. We would like to have this only as options. To reduce the data, we would like to focus only on the route which is provided by the person in charge to plan the route. Of course, in our application can be option to put more than one and checking few of them. Everything depends on the needs on the clients and technical possibilities regarding the connection and data bandwidth.
Why do you think that the end customer would prefer this route with the minimum size than the area? Why you think so?
Well, the main motivation for this is reduce the bandwidth, so the cost on the sending the data to actually end user. Of course, it's no problem to send more data when user requested it, but our basic product assumes that only the information along the route will be the main reason is to reduce the data which are sent from the servers to the end client. And
because what if the route changes and the client, are you able to quickly react and to provide additional information?
Yes, well, our initial idea, so for the MVP, assumes that each client can have several routes in the application, so it can be chosen, and a few variants of the routes. Whenever client is requesting the server, the idea is to provide the newest data which are on the server. So whenever something will change on the ship, if this is possible, to send the request to server, so there is a connection, we will respond it with our newest information.
Any last questions from the jury to Arthur? Yes, Miko.
A quick one. So when there's sea ice, the shipping is always behind an icebreaker. So the routes are given by them. So I guess your application has more room in the non-sea ice areas, or otherwise you need to somehow have a relationship with those ice-breaking services. Do you have which solution?
Okay, so minimum value product assumes just the area we found without an ice. I mean the shippable without the icebreakers. Regarding the service, which in the future development, we can consider to include the information about the route which were created by the icebreakers, but that's required some further development and cooperation with other companies and the source of data.
Super, Arthur. Thank you for also your brief response to this quick question of Miko. I am sure the jury has enough information to deliberate, and we can continue. Arthur, thank you so much. We wish you all the best of luck, and thank you so much for being with us this weekend. It was good to see you again, by the way, because we already met on Sunday.
Yes.
And
thank you.
Very good pitch, if you ask me. Katrien, What was your opinion?
Yes, indeed. It's not easy, especially if there are several solutions that are a little bit in the same topic. It's not that easy to come to more towards the end, because then you have to start showing what your unique selling point is. So I think job well done. And I would suggest then that we move on to the next pitch. We are joined here by Bianca Balan, the winner of the hackathon in Romania. Welcome, Bianca.
Hi, hello everybody. Nice to see you all.
Nice to see you as well. I believe you're going to tell us more about your project Horus.
Yes, our project is called Horus, and we tackled challenge number 2. Picture this: one random day, boom, you have no reception, Wi-Fi is gone, trains stop circulating, total panic. These are the risks that millions of people face in the Arctic. Extreme weather and landslides make it incredibly hard to build and maintain infrastructure. We expect heavy investments in the Arctic over the next 10 years, but there are billions projected in infrastructure losses until 2050. Our solution is Horus, an integrated IoT platform for remote monitoring of the environment and health of field equipment. We use Wikio data to fetch ice thickness, snow melt, and satellite pictures, among others, and in situ sensors for pinpoint accuracy. Horus enables the visualization of relevant information, has a customizable dashboard, and an alert system. We offer telecom providers, industrial players, and even scientists a portable solution that lowers maintenance costs, makes field operations safer, and allows them to mitigate potential disasters. Accuracy and readability aside, our platform is special because it's 100% reliant on satellite communication. We will link our sensors to the SI Iridium network or a dedicated network of CubeSats. No downtimes. Our team is young, but we have experience with IoT and building complicated platforms. But the thing that excites us the most is the future outlook. It is the perfect time to partner up with other space startups, integrate prediction models, automate what we can, and build an entire value chain based on the new space industry. We bundle up nicely, sell it as a service, and together with our customers, ultimately ensure the livelihood of those in need. Thank you very much for your attention. We are ready for questions now.
If I may say so, excellent pitch.
Thank you. I was really nervous.
Let's see what the jury members thought. Miko, I see you smiling.
Everything. Now, well, I think that the sound in the background was, of course, a little alarming. I start. I think the point is that your opportunity horizon seems a little too wide. So, explain one example of something where you could concentrate first. What would it be?
Yes, you are perfectly right. But as you know, Romania is a bit far away from the Arctic. So we do indeed need help from some mentors and from local industries leaders to help us narrow down the market and find the right segment and the right verticals where they need our solution first. We identified problems. We saw numerous articles on BBC and Sky News that pipelines are in danger over the next years, and telecommunication failings and railroads failings. So we do indeed need to focus down and pinpoint where the need is the most. But I think to have a sensible judgment on this matter, we really need to be there, like maybe not physically, but to talk to someone who really knows the underlying machinations of the industry there.
So is there a particular set of sensors that you're considering? Because your solution is sensors and satellite communication, basically.
Yes, so we have a sensor, an IoT sensor here in our office that we use for studying some metal in the ground, how the metal erodes, in partnership with the Polytechnic University of Timișoara. and they go up to minus 40 degrees. We probably need to find some sensors that can maybe withstand a little bit more, but considering the fact that this sensor is just a normal sensor that costs like $100 maybe, we need to definitely check in and find a good provider for this.
So are you looking at solutions which involve metal erosion?
Yes, so this is where we have currently experience. So we've built IoT systems for factories, and we did this project with the university, and we really need to dig down and see how these equipments really respond to the Arctic weather, because research is not that available in that region. So you can find a lot of literature regarding the metals here in normal conditions, like normal soil, but there in the extreme weather conditions, we really need to dig deep.
So what exactly you want to show on this dashboard? I understood that you developed a dashboard with some set of data from Copernicus. You were mentioning, for example, snow melting and so on, but what all the data you want to collect, how you want to filter it, and then I also wanted to understand to whom you want to provide it, but I think this question was already here, because then you were talking about also about pipeline. So what is the clear idea right now on what kind of data for who you want to collect and how it's going to look like?
So it is an IoT system designed for engineers that built these systems. So they can have an overview of the meteorological conditions and of the environment conditions in the area. So they can see how the equipment is doing in those conditions. So we take satellite images and we correlated them with snow melting and ice thickness. And then you can have a really good picture at the macroscopic level on what's going on in the area. Do we have a landslide that's coming? Are there floods happening? And so on. And for the sensors, we can actually pinpoint the metrics and see how the individual endpoint is doing in that area. Of course, for the prediction part, we didn't do that in our proof of concept now, but we found some theoretical foundations for it. And ESA also recently published some studies regarding the permafrost. So we have a clear path in that direction as well.
Okay, I don't hear any more questions from the jury. So I believe we're going to wrap up this pitch and move over to the final two pitches of tonight.
Yes, I think so, Anne-Catherine, but thank you very much, Bianca, for your pitch. You did very well. I think you have an exciting journey ahead in product development because your team will indeed have to design some hardware to be used in a harsh environment. And that won't be a walk in the park from an engineering perspective. So she definitely got my attention, basically, Anne-Catherine. Thank you and all the luck. We hope to see you back later on the evening. Indeed, pitch number 8. I think our jury members are still up to it. They seem to look very energized still, so I can see them nodding and smiling. And they are on top of things. So thank you for that. And have a drink, please. Water before the deliberation. Afterwards, you can have something else, obviously. I think our next winner is coming from Slovakia. Marco Isaac Marin Granados, and I'm just sneaking a little bit to the right name, is joining us from Slovakia. Hello, Marco. How are you doing?
Hello, I'm fine, thank you. How are you going?
Super, super. What do I see in the background, Marco? Is it a surfboard or is it something else?
Yeah, it is our surfboard. It's part of our mindset.
Okay, it's part of your mindset. Well, Marco, you have 2 minutes to tell us all about Energarctic. So we are all ears. Floor is yours. Good luck.
Thank you so much. Ahoy, my name is Marco Marin, and together with Natalia Espinosa and Alvaro Carpintero, we are building up Energy Arctic. Using Copernicus space data, we locate the optimal locations for deploying wave and tidal generators. Energy Arctic offers space-based data analysis solutions for where and how to extract the maximum amount of energy from the Arctic Ocean, keeping in mind wildlife safety, ecology, sustainability, energy access, and cost. And probably you're wondering why this technology of wave and tidal energy generators is necessary. But in the Arctic, 80% of the electricity supply is based on fossil fuels. Nowadays, the levelized cost of electricity of this technology can go as low as 200 euros per megawatt hour, which represents a half of the diesel generators. The latest predictions estimate a growth of 37%, reaching a market size of 14 billion euros by 2027. There's a wide range of potential customers for Energy Arctic. For example, government and municipalities are always interested in diversifying their energy supply. Energy farms operators are looking for better efficiency and forecasting. Manufacturers also need support for improving their solutions for technology, innovation, and their own site operations. This technology is already being limitedly used and researched in several locations all around the world. For example, in the European Marine Energy Center. And also companies like Solar GIS and BestScreen already offer intelligence services for solar and wind power. So the market is still very growing. Together, powered by support of EU programs and venture capital investments, we will data serve this energy wave to the Arctic, but also to the rest of the ocean world. Thank you.
Thank you, Marco. I've seen a lot of pitches and presentations, but you really got my sympathy for your creative approach in introducing slides into this pitch. And I'm sure our jury members will have some questions on that. Floor is yours, ladies and gentlemen.
Yeah, thank you, Marco, for your presentation and your pitch. Do you propose in your solution a complete study of potential site for this kind of marine renewable energy, or this is just to know the potential power? I mean, do you take into account, for example, the site access, the ice coverage to access to the power?
Yeah, the MVP that we have developed during the hackathon consider basically the potential energy that can be extracted in a specific point. Nevertheless, we are planning to integrate also Galileo and Copernicus data to have information regarding, for example, variables such as the ice velocity around the area, and also, as we were mentioning, like take into account like biofactors that could address to possibly like some interference of wildlife such as sea whales and so on. Nowadays, most of the projects that are ongoing have taken into account these considerations, even though they are mainly like in contained spaces, let's say. But yeah, thank you.
Do you have connections with, so when you are proposing kind of like to be able to help to find places for this energy production, then you have obviously those companies who are doing those solutions. What are your connections with them? Isn't that your main customer?
Yeah, this is, I mean, like it's a tricky question because the legislation, let's say, of each of the countries where this kind of energy could be used is slightly different. Nevertheless, in the Arctic specifically, for example, research facilities, most of the time, like they are on just like, let's say, international waters, or sometimes on zones that have, like, there is no real legislation, let's say, for a specific given country. So most of the times, like, they are producing their own energy by using, for example, these diesel generators. And I mean, it's quite sad because most of the times, like researchers, they are trying to increase or enhance the quality and the wildlife, for example, like ensure the wildlife. But by the end, like also going there, they are also harming somehow the ecosystem. So yeah, I mean, like it is very different. And also, I mean, and another point is like, for example, for these areas that are in the Arctic, but still in continental zones, Many times, like they are very, very in the north, and there is no a real connection with transmission systems, or even sometimes with distribution systems of power. So they deploy their own generators, and they are like having like an island system or an like on-grid system. So yeah, I mean, like it is a quite a specific situation that has to be taken like one by one, let's say case by case. But by the end, like the intelligence and the information that they all need is quite similar.
Maybe I was a little imprecise. I meant wave energy companies, or tidal energy companies. So those that you propose that could be using it.
Yeah.
You have connections with them.
And nowadays we don't have already a developed connection with them. Still, they are only like one of our catalog of customers that we think that require this kind of information. Well, I mean, luckily nowadays the market is just starting to get mature. So if we get positioned in this early stage, for granted, we will get a good market share of it.
Do you think your customers are going to need data on a recurring basis, or just when they're setting new things up, or like, yeah?
Yeah, sure. Thank you. Well, actually, these kind of energies, very similar to what happened with almost all renewable energy, are very dependent on data, because you need to predict how much energy and when you will have it and so on. And I mean, like, for being able to interact also with some other generation technologies. So yeah, our business model relies on a subscription based, because by the end, our customers require a constant stream of data, and also not only the data that we will be providing, it's useful for the starting of the project, but also for the continuous operation of it. Because by the end, for example, one feature is like the maximum power point of tracking that allows, for example, for maximizing the energy that you will require. And for example, in wave and tidal energy, you have to set the turbines in a specific direction according to the direction of the sea currents. So yeah, and that is just, for example, a simple variable that is very dependent on the information that we will be able to provide. Thank you.
Maybe a last question from the jury. No.
I was thinking or wondering about the data processing. So what kind of data you will offer to these companies that they cannot get by themselves?
Yeah. So first of all, I mean, even in this early stage of our MVP, we are already creating like visualizations of actually the real, the potential power that could be generated by using given models of turbines. So for example, probably for sure for different clients, such as government, that they are more focused by the end, like in just gathering the data and getting an executive report. Probably this is not their focus. Probably for some other academic communities, let's say, it could be an interesting point of view, like to get access to more raw data. But by the end, like the information that we are providing also, for example, allows to go beyond just deploying the turbines, and also be able, for example, to move the location of a given turbine to another place, because that's one of the characteristics of this technology. What is really useful, for example, for the operators that will start deploying like these wave farms. So they can, if there is a place where in the given season it will decrease the production, they can quite easily deploy a ship to just move the turbines and keep a high production rate. So for example, that kind of information, it's for sure something that it's not so accessible for competitors, let's say, or for our customers.
Marco, thank you very much for bringing some more clarity, and we wish you the best of luck tonight. Anne-Catherine, I think we are almost up to number 10, isn't it?
Almost. We are at number 10. Oh. We're going to hear the final pitch of tonight, and we're moving to the winner of the hackathon in Spain. Fernando, I don't see you yet, but we will welcome Fernando Hidalgo Pineda, who will tell us about Wild Tracker. There we go. There you are. Hello.
Hello, good afternoon, everyone.
Good afternoon. How are you?
Good. Well, must confess, I'm a little nervous, given that I'm the last one, but yeah, sure.
Indeed, a little bit of pressure, but I'm sure you will do well. Your 2 minutes start now.
Wonderful. Thank you for your kind words. So as they said, my name is Fernando, and I'm delighted to be here today introducing you to our project, which is Wild Tracker. During those 48 hours of hard work in hackathons, our little 4-integrant team shared their concerns regarding probably one of the most urgent problematics within the Arctic. That is precisely because of the effects of climate change, but also economic pressure. There's been this urge for the creation of new routes across the Arctic. But at first sight, this comes in very contrast with the idea of protecting the environment. So our point of inclusion was, okay, do we really have to think of these two as in contrast? Why not using them as tools? Why not expanding this logistic network for higher latitudes while protecting endangered species? So how did we do this? Well, we analyzed and compared essential climate, terrestrial, marine features obtained from Copernicus and positional information gathered by Galileo with information extracted from this monitoring of the seasonal displacement of animals across the North Pole. And this is by comparing and contrasting them that we construct the foundations of our idea. Building up from them, we come up with Wild Tracker, which is the software that can predict in real time changes within these migratory paths for Arctic species, and accordingly to that, suggest alternative, optimized logistic routes for their users. The power and potential of Wild Track at business level, for instance, resides not only in our ability to reduce cost by implementing these new routes, but also increasing the demand by putting forward an environmental and consumption certificate. As you can imagine, this requires quite an interdisciplinary team, which in our case was composed by Ximena, who was our biology expert, Elena in charge of telecommunications, Tiberius, our full stack developer, and me, Fernando, as a space expert. Thank you very much for having us, and we're more than delighted to help you with any question you might have come across during our pitch.
Thank you very much, Fernando. Job well done. Let's move over to the jury for the final questions of the evening.
You say you're making a wildlife tracker. Can you expand on that? Are you looking at what exactly are you looking at there, and what are you tracking?
Sure. Okay. Okay, I'm not quite sure whether I fully understand it, but I'll try to expand on it. We didn't really want to focus on at a certain level. We wanted to tackle all the species that are endangered within the Arctic. So the idea is to use information from Copernicus and Galileo for positioning and features about climate, for instance, and support all that information with data that we can obtain from external institutionalized researchers, for instance, and about animals. But our idea is to go beyond that. So Galileo already has a technology to keep track of this motion of species across the Arctic by using its imaging capabilities. So that would simplify much better our task and give in real time precision. So yeah.
Thanks.
I think what Katriona was going after is maybe give us an example of some kind of marine, for example, wildlife. How would you track them, and what are then the kind of customers for this? Because what would be the business idea to get this funded?
Okay, certainly, yes. So let's say, for instance, a type of whales that can be found in the Arctic. We found articles that keep track, institutions that keep track of their seasonal motion across the Arctic. It is quite hard to keep track of that. So we base our data also in other factors, such as, for instance, let's say chlorophyll. And regarding the business related question, I must say initially our idea was to tackle NGOs and governments because of the protecting environment side of our idea. But then thinking more about it, it is true that it wouldn't be feasible because of the economic implications to do that just for that segment of the population. So the idea is to go beyond that and tackle all businesses that use transportation and logistics to carry their products across the Arctic, and increase their demand by introducing, as I said, that certificate, but also reducing the costs. So that's how we would base our business.
Any final questions?
No, thank you so much for this last pitch. And I think, Fernando, the jury has to start deliberation. So we say for now, goodbye to Katerina, Fabrice, Mikko, and Katrina. We'll see you back in a couple of minutes after the deliberation, because you will be all introducing the top 3 winners. So I'm so excited. Good luck with your deliberation.
So what are we going to do in the meanwhile?
In the meanwhile, Anne-Catherine, we have a jam-packed agenda while jury is deliberating. We will be having some guests, some local organizers will tune in with us. I think from Germany, Finland, I have to sneak a little bit, Italy, France and Slovakia are tuning in.
Ah, nice. I really like this virtual traveling around Europe that we've been doing throughout the whole hackathon.
It's different, but it's exciting indeed. I think our first local organizer I would like to invite to come on our virtual stage is Michal Brichta from the Slovakian Space Office. Hello, Michal.
Hello, good evening.
Hi, good evening. Michal, did you catch some sleep last weekend?
Yes, a little bit, but it was too exciting to have more sleep.
Yeah. How many people were participating in your hackathon in Slovakia?
Yeah, so we had at the end 6 teams, 6 amazing and quite diverse teams of in total 26 people.
Yeah, great.
You were a fully virtual hackathon, right?
Yes, indeed. We decided to turn into virtual due to the current situation.
Yeah.
And we were happy that even though we turned virtual, we managed, and with the great support of our mentor team, to keep people engaged and collaborating well. So that was quite challenging, but at the end it went pretty well.
Any specific activities that you did during the weekend together with the participants then?
Well, we understood that they need a lot of time actually for the hacking, so we didn't want to overload them, but we were basically 24/7 making sure that they have a person to chat with, to discuss their idea and their progress. So this was amazing to see our active mentors, that they were circulating the Discord channels and checking team by team and popping up to some random video chat and discussions. So I think that they really provided amazing support.
Michal, if you have one tip to the participants, what would that be? If you could give them one piece of advice.
Then it would definitely be continue. Don't keep your activity here at the hackathon, but use it as a starting point. And if you even don't continue in this particular idea, then it doesn't matter, because there are many possibilities how to utilize the satellite data. So don't stop here. Let's begin.
Super. Thank you, Michal, for your participation over here. Anne-Catherine, I think we have somebody else in the lineup.
Yes, indeed. Michal, stay on the line, but for now, let's jump to Aude Nzeendong from Aerospace Valley, the local organizer in France. How are you?
I'm fine, thanks.
How has the weekend been?
Impatient to see the final results of this hackathon.
So it seemed like you had a lot of lively interaction going on during the weekend, what we saw on the live carousel. Any specific activities that you've done to keep the energy up, to get together with the participants?
Yes, exactly. We make a physical event, and it was really great. Since from 2 years we didn't made any hackathon as a physical event, so it was really great. And as you said, it's important to keep the energy. There was a lot of food and also some presentations and a photo stand, a photo booth to be able to have some photo during all the weekend, and a lot of people to support and to come to discuss. And indeed, it was really a good group. At the final, we had 34 people, and it was really great. There were 7 wonderful teams, really.
Super odd. Nice to see you again, because we were a few weeks ago in Germany. And I know
Yes.
French people like to drink coffee. So how many coffees did you serve during the hackathon weekend? Any idea?
Yeah, too many. Yes, there was a lot. And we have really take care to have enough and not to miss of coffee at one moment. So it was perfect. I think we should have something like 18 liters, I think, during all the weekend.
I wouldn't expect any liter less than 18 for France order. Nice, energized team, energized organization. Thank you. Maybe we have the time to come back to you, depending a little bit on jury time to deliberate. Nice to see you again. But I think we also have Maria Cristina Porta from Italy, Head of Incubation and Open Innovation at Como Next. Hello.
Everyone, hello, how are you?
I'm fine, I'm fine. And
a very long journey, this hackathon.
Sorry?
A very long journey, this hackathon.
Yes, yes. How did you experience the hackathon over there?
It was the first one for us, and it has been really exciting. We are ready for the next one. We did it both in presence and in a virtual way. We had 35 people, around 35 people participating in 5 groups. It has been really very, very interesting because we had participants even from abroad, foreign students that are completing their studies in Italy and they participating. And it was very an intensive experience. We had technical mentors from aerospace, environmental technologies, marketing in presence, and parallel sessions online. So sometimes you couldn't observe the mentors. They were so involved in the teams that they were the same thing.
So this was your first hackathon, and it was immediately a CASSINI EU Space Hackathon. Is there anything that you've learned about EU space technologies this weekend?
I personally, it's difficult because I have an economical background, and so I could appreciate not the technologies by themselves, but their application through the projects proposed by the groups. So I think for the market is interesting to understand what they can buy, which kind of solution they can obtain. So I personally couldn't appreciate the completeness of the technical aspect, but the effectiveness of technology, yes, that was so interesting.
Super, Maria Cristina. Our compliments and congrats for successful organizations, just like any of the other 9 hackathon organizers in Europe. Anne-Catherine.
Thanks to you for all support you gave us. Thanks so much.
It was a pleasure, but our team will definitely take gratitude for that. Anne-Catherine, we have another one tuning in.
We're going to Finland, where we have both Sofia Ramos and Chitran present with us today. Hello.
Hi there.
Hello. Hello. How's it going?
Really good.
Tired after a long few days or still energized?
I think for me, I think I'm still energized. Yeah.
For me as well, yeah. Now with the demo day, quite a lot of energy.
If you're so energized, I wonder if you could participate yourself in the hackathon, what project would you have submitted then?
That's a difficult question for me, for real, because we were so focusing on organizing the event that yeah, there was no brain left to come up with idea. What about you, Sophia?
I think for me, the most interesting challenge was the wildlife.
Yeah.
I think I'm very keen on animals, so maybe that is why.
Yeah, cool. But engaged organizers as well, and Catherine, you have a question for them?
Actually, I saw some posts on social media passing by. I saw you had some partnerships going on. So can you tell us a little bit about the prizes that you offered from Nordic Startup School?
Yeah, so
Yes.
Yeah, Sophia, you say talk about that.
Okay, sure. So we actually got 3 prizes in total for the first 3 places. And then the first prize was 5,000 euro, and that was sponsored by ISI, Finnish company. So you can go and check that out. And then the second and third prize were organized by CASSINI and Nordic Startup School.
Wow.
Super. That's great prizes, basically. And thank you for being with us this entire weekend. I think a lot of appreciation for what you guys have been doing over there. I think we also have Leonard over here. Leonard Nima from Germany, and he's the co-founder of Nextcoder. Isn't that Leonard?
Yes, exactly. Good to meet you again. Hi, everyone.
Hi. How did you experience the weekend?
Well, it was an intense journey. So overall, really a big success. I would say it's not an easy one, right? The topic is not easy. When you think about space technology, space data is not easy. Then putting this into the context of the Arctic makes it even more difficult. So first of all, high five to everyone, all the teams out there working on this, because this is really a brainer. And I think this was great to see that you get into something, that the teams get into this. They struggle, of course. They need to find the ideas, and then they need to find solutions, how to deal with data. I think this was really, really cool to see how far they have gone, even in this short amount of time of just 2.5 days.
So perhaps you don't have a space background. Why did you decide to organize a hackathon that focused so much on EU space technologies?
I mean, maybe elaborate a little bit. With Nextcoder, we really want to look in how can we use the latest technologies to create positive social and environmental impact. So everything around the sustainable development goals, that's anyhow what we do. So not just using technology for the sake of technology, but for making really a positive change. And we've been looking into machine learning, blockchain technologies, you name it. And space technology has tremendous potential, space data. And that's something that we also learned with them just throughout the Big Ideas campaign, that we learned from all the experts who contributed. There's so much data, so much potential out there that we can really tackle some of the big issues. And I think this was what was fascinating everybody at Nextcoder. So everybody got really excited about this.
I think, Leonard, indeed, Cassini hackathons are also a discovery, basically, for everybody, how space technology can be implemented, used, and how to contribute to basically quite urgent societal problems. So thank you for being here, because basically I was informed, Anne-Catherine, that the jury had came to a verdict. So basically, I think one way or another we have to rush and basically get back to them, if you ask me.
Yep, indeed.
We will be announcing our top 3 projects.
Well, I can only imagine that it was a tough decision, because all of the pitches that I've seen tonight were very interesting projects, very well done, and they've really used EU space technologies very creatively to connect the Arctic.
I can agree with that entirely, and I see that the jury is basically coming into the virtual studio again, bit by bit. So I think we have to basically get in touch with them in a second. Welcome back, Katrina. May I ask you to join us and tell us how it went basically in the deliberation?
Sure, definitely. First of all, thank you for having us. Some super interesting topics. I not only learned something, but we heard some very different implementations and different solutions. It's really clear a lot of work went into this, and like a lot of different solutions being presented. And I'm a bit biased, but it's very cool to see how space technology can be applied to solve real life problems. It was super tough to choose. Everyone did a really good job. But yeah, let me pass on to the other jury members to announce the winners.
Thanks, Katrina. Indeed, the time has come to announce the winners. And we'll start with the third place, who will be announced by Mikko.
Ooh, tension is growing. Who will it be? Well, I give a hint, which is very simple and dear to me, because it's a Sentinel-1 kind of application. I have by myself actually made the Sentinel-1 mosaics for Finland, and that's why it is great to find that someone else is working on the same thing, did a really nice, simple product out of it. So IceBlink, the French winner, you are third. And it's a very, very thin margin to the others. So I think that all of the three winners are very tight together and all of them were good. IceBlink, you are number 3.
Congratulations, IceBlink. Zoe is still enthusiastic.
You may now scream and shout and jump, please do.
Mais je vais arrêter le micro avant parce que je suis gentille avec vous. Sorry, I'm going to stop the microphone before I scream and shout because otherwise it's not very nice for you.
Nicely done. Congratulations. What a lovely achievement. But we also we have a second place, isn't it, Fabrice?
Yes, so personally, I very much appreciate this navigation solution in line with the the needs of the local population. So the second place goes to Polar Bearings.
Congratulations, Polar Bearings. I saw a very excited reaction.
Yeah, I mean, I mean, I hope it's really obvious, but like the whole team has been just so passionate about this idea that it's really incredible to have this recognition. Thank you so much.
Well, congratulations again. And now, for the moment we've all been waiting for, I'm pleased to welcome back Katarina to announce the very first place winner.
So thank you very much. I'm very happy to announce the overall winner of the second Cassini Hackathon, Connecting the Arctic. That is the team, and it was very difficult to decide, that has developed the idea for the identification and detection of landscapes at risk for erosion, and managed even to establish the cooperation. So the winner is the team from Iceland with the idea Arctic soil erosion. So congratulations. Woo!
We can definitely see some happy faces over there. Hello, winning team.
But it will be super strange.
Thank you so much. We're really excited, as you can probably hear. This is really cool.
Sorry.
Our team can't wait to just continue on with this project. We really think that this is something that's going to go far, and we just are excited for the future.
So are we. We are looking forward to give some mentoring and to provide the 3 winners with some top mentoring experts in order to bring you all one step further. And it makes me so happy to see so many happy, enthusiastic faces and giving their sincere reactions in this live stream. So well done, everybody. I think on behalf of the whole team you've seen tonight, but also over the entire weekend, we want to congratulate our 3 winners. But we also want to congratulate basically all the participants in this hackathon, because 270 people have been busy over an entire weekend in order to develop solutions. And you have all been contributing to raise awareness on the importance of our Arctic, and also basically helping to design some ideas and solutions which provide a sustainable future for this region that is of utmost importance. And that is what we've seen in the past few weeks in the press related to basically the climate conference in Glasgow, that the Arctic is really very, very important. So basically, thank you very much, and congratulations to everybody who has participated and picked up these challenges, Anne-Catherine.
Indeed, very well said. We would also like to thank the European Commission, the Wikio Dias, all of the local organizers, experts, mentors, and speakers who have contributed and helped the participants learn and develop their ideas over the weekend. Finally, a big thank you again to the participants of the hackathon. We hope you've had an amazing weekend and that you continue to use your skills and knowledge to make an impact.
And last but not least, Anne-Catherine, we have to thank our jury members of tonight. I mean, they have done an amazing job keeping up attention for 10 pitches, basically posing spot-on questions and doing a harsh deliberation. I think, ladies and gentlemen, I think you deserved a glass of wine or a beer or a non-alcoholic thing. Great job. Thanks for being with us, and we are looking forward to meet again in the near future. So see you around. Anne-Catherine, we are coming at the end of our show, I think.
Yes.
Then there is not much left to do. Then
thank you and goodbye.
Thank you and goodbye, everybody.